In this problem, we generate hydrogen using zinc and hydrochloric acid. And the hydrogen is collected over water at 16 degrees Celsius. And the total pressure in the collection of gases is 752 torr, which includes the contribution from the hydrogen and the contribution from the water vapor, since it was collected over water. Total volume was 1,495 milliliters. Use table 5.3 to help calculate the partial pressure and mass of hydrogen. Okay, the strategy here will be to start from the total pressure and, using the partial pressure of water vapor at 16 degrees, calculate the pressure of H2. Then from the pressure of H2 we could get the number of moles of H2. Since we want the mass of H2, we can use PV is equal to nRT. We have the information of the volume and the temperature and so forth. And then we can do a mass to mole conversion to get the mass of H2. So that's a reasonable strategy to start with here. If we look at the parameters we have, first of all, the temperature is equal to 16 degrees Celsius plus 273 will be 289 Kelvin. The volume is 1,495 milliliters. To convert that to liters, we divide by 1,000, so this would be 1.495 liters of this gas. Now, since the P total is equal to pH2 plus pH2O, we have to go and look up the value of pH2O in table 5.3, and that turns out at 16 degrees Celsius to be 13.6 torr. So we have 752 torr is equal to pH2 plus 13.6 torr. So the first calculation, we can show that the partial pressure of hydrogen by itself is 738 torr. That's the first part of the problem. It's a mixture of gases. We subtract 13.6, the vapor pressure of water, from the total pressure. We get the pressure of the hydrogen. Now, if we want the number of moles, we can use the ideal gas equation, and we'll solve that for N, for H2. This will be P of H2 times volume of H2 divided by R times T. So the pressure of the hydrogen is 738 torr. 738 divided by 760 would be the pressure in atmospheres. And then we're going to multiply that by the volume, which is in liters, 1.495 liters. And we divide this by, first, the universal gas constant, 0.0821, and then by the temperature in kelvins, 289. And if we carry out that arithmetic, we find out that the number of moles of hydrogen is 612 moles. 0.612 moles of H2. So we have one step left to go, a mole to mass conversion, 0.0612 moles times 2.00 grams of H2 per 1 mole. H2 gives us 0.122 grams of H2. So these are the steps total pressure is adjusted using the water vapor at this temperature to get the pressure of hydrogen. Pressure of hydrogen is used to calculate the number of moles of hydrogen, and from there, the mass of hydrogen.